a debt of thanks to Peter Schmolk for having gone to the trouble of converting the Q-method software package, which is a mainframe package initially, into one for PCs. There is not a Mac version yet. I don't know if there ever will be one, but at the moment only for PCs. And I think most of you are probably familiar with this, or if you're familiar with Mike Strickland's PCQ program, which has been around longer and will soon be issued in version 3. It does essentially the same way. Both of them were created with the assistance of Stevenson, if not directly, certainly inspired, and all the principles that we came to understand were principles that he desired in a factor analytic package are in there, which makes both PCQ and Q-method unique compared to all other factor analytic packages worldwide, as far as I'm aware. There's others that do similar kinds of things, but all packages are not equal. These have certain theoretical presuppositions built into them, defensible ones, incidentally, not always completely obvious to those who don't understand yet, but nevertheless, that is the case for both of those. So either one or both are strongly advised. The Q-method program begins on the mainframe version, and I'm somewhat uncertain in manipulating all of this because I've been mainframe oriented for about 20 or 25 years, and they're just now withdrawing life support from mainframes all over the place, which is, I'm glad, has forced us into I just bought my first PC a few months ago, and in fact have not loaded up PCQ, which Q-method, which I understand works exactly the same as the mainframe, and so far as I can tell, that is the case. So I may make an error and inadvertently erase everything here in a moment, but I'll try to avoid that. On the mainframe, it begins by simply putting in XQ. At least that's the IBM version. I'm not sure about the VAX version. And it then starts prompting you and is very menu-driven. It asks you what name you want to give the file. I've already done that. It asks you then how many statements are there. You tell it that. It asks what is the most extreme negative score. In this case, I put in a -2 because that was the most extreme negative score. What is the most extreme positive score? +2. How many statements? To give then the number of statements that goes under each category. So in this case, it would be 3 under -2, 3 under -1, 3 under 0, and so forth. You put that in, so it knows how many statements there are, what kind of shape they're supposed to look like. It does not restrict the shape of individual Q sorts. If somebody has put 14 of them under +2 and 1 of them under -2, it'll accept it. So it will take free distribution, but it takes the forced distribution as a model. And some questions were asked at the end of the last session about that forced distribution, and we want to get back to those a little bit later. But it's in no way a constraint on data entry. That's the main thing. You then put in the Q sorts, and I put in 4 of them out of 6. Now, it's not because of any favoritism or anything of that nature. I've selected out 6 of these, and I will do my best to analyze all 30 or however many once I get back to Kent and send them out over the Q network or something like that, so that you can see what factors were really at issue. But when it comes time to selecting people to do the Q sort, the so-called P-set, it is typically structured in the same kind of way that Q sample is structured. That is, we anticipate that there's going to be certain kinds of effects. We anticipate that there are going to be certain kinds of people that are going to produce factors. Now, we may be totally wrong. The factor analysis will correct us, so there's nothing lost by being wrong initially. But rather than sort of just going out and getting anybody, we usually try to get people who are theoretically saturated in some kind of way. If we're doing introversion and extroversion, for example, I might go out and get some party animals on the one hand and some librarians on the other hand, or specifically look for people who either by profession or in some other kind of way I would expect to be introverts or extroverts. Or if I was doing a study on candidate perception, I would purposely go out and get some Democrats and purposely go out and get Republicans rather than just sort of taking the first person who walks in the door or taking a random sample out of the phone book or anything of that nature. So you're looking for respondents that are focused because of their characteristics that are focused on the study in the sense of having those characteristics that we anticipate a priori are probably going to be potent in some kind of way. So in this case, for example, and I don't mean to embarrass anyone, but Julio Barbosa, simply because here's somebody from a medical school context, along with Bob Murtak and Marcia and Ulrika and others. He could have taken any one of them. Their needs, their reason for getting interested in Q could be quite different from other people, or different with regard to some kind of emphasis. John Carr, coming from communication and from Australia. I picked his out of here as well, more for communication than for Australia. I doubt there are national differences with regard to Q methodology, although with the British I might make some proviso there, because sometimes I think they may have some. Mike Knight, because there's obviously a group at the Central Oklahoma Mafia that so having someone, again it could have been any one of them, because presumably there's been talk amongst them so that they share certain kinds of concerns because of the things that they have discussed, and really getting anyone from that group. Eleanor Allgood, primarily because of being in kind of applied setting in the sense of psychotherapy, and therefore seeing something in Q that is related to these therapeutic interests of hers. Brian Midgley is someone associated with the interbehavioral kinds of concerns of Cantor and so forth. Peter Schmolk, because of his interest in the computer kinds of aspects of Q, technical kinds of things. So all of these people may end up, it'll just be my luck, being all on the same factor, and we won't get any variability at all. But on the other hand, we can enter these and see, in fact, what we do get. And I've already entered in the first 4. I think this is respondent number 4. And if you may want to keep track of this, incidentally. Number 1 is Julio.
Joylo.
Pardon?
Joylo.
Joylo, sorry. Joylo. And John Carr, right here. And communication is number 2. Number 3 is Mike Knight, sitting over here. Number 4 is Eleanor Allgood, sitting over here. Number 5 is Brian Midgley here. And number 6 is Peter Schmoke right here. So we're ready for respondent number 5, who in this case is Brian Midgley, and it prompts you and asks you for the statements that are in the -2 columns. So I would just put in here 15, 4, and 11. Return, it goes to -1, 14, 13, 9. Under 0, 1, 3, 10. Under +1, 2, 5, 8. And under +2, 12, 7. Now let's say I put in 16 instead. It's supposed to be 6, but if I were to put in 16, just for those who may not have seen this before, it immediately tells you that there's a mistake, that there are some statement scores that are higher than the number of statements that you've got, and that there is a statement number 6 which is missing. It then asks you to examine the Q sort and to pick out the offending column, which in this case is the +2 column, so I just put in a 2. It tells me those that are in there, so if I put in 12, 7, and 6, it'll come back and tell me that the sum is 0, which it should be because there's a +2 to balance off the -2s. The mean is 0. If you have someone who does not follow the distribution, obviously the mean will be off and the sum will be off, as you would expect it to be. But it gives you a picture of the keyboard so that you can examine it if need be. And then it says, do you want to change it in any way? I say no. Do you want to add one more Q sort? I say yes, and that's number 6, which is Peter Schmolk's, and it's 7, 5, 4, 8, 3, 1, 11, 15, 9, 13, 12, and 6, and 14, 11, and 2. Whoops, and I've got a mistake already. Whoa, it's not my mistake. Sometimes this happens. You know, I have 2 statement 11s. Those 2. Can you tell very quickly? This I knocked off. Can I just put it in my pocket? Did I do? All right.
So there's a check.
Pardon? This one.
Oh, okay.
Yeah.
So there's a check on double entries?
That's right.
Yeah.
That's right. Anything that's aside from free distribution, it won't correct you on that. It'll merely show you what the mean and the sum is. But otherwise, if there's something that is illogical, statement 16 is only supposed to be 15 statements, or 2 11s, and what you see.
This is right.
So, and this should be what?
The one missing.
Oh, the one that's missing. Oh, okay. So this is, that one's okay. So under 0, number 10 is the one that's missing, and that's under the 0 category. So that should have been a 10, 15, and 9. Okay, now everything is okay. Do you want to change it? No. Do you want to add another Q sort? Also no. All right. One thing I do need to check, though, I'm not sure about Q sort number 1. You can go back and review these. If I went to show a Q sort S, it was Q sort number 1, and I want to check this 1, 2, 14, 5. Nope, that's okay. All right. I want to exit this part. These are the various steps in the process of entering the statements, which I've already done. It just takes statement fragments up to the first 50 characters of a statement, and I did that over the break, and we've just entered in all the Q sorts. The next one is the correlation, and as I'm sure you're aware, spend a little bit of time on this part of it. The correlation is fairly straightforward. The formulas are all the same as they are in our methodology, and so if you've got a basic course in statistics that included correlation, then you have all the information that you need. But just to go through a concrete example, you take any, well, let me use 2 that we have already, number 1 and number 2, let's say. We have 15 statements. So, statement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2 Q sorts, number 1 and number 2, or let's say A and B. And statement 1 gets a -2 for this person. Statement number 2, a -2. Statement number 14, a -2. Statement number 3, a -1. Statement number 12, a -1. Statement number 4, -1. Statement 11 gets a 0, also for statements 6 and 8. Statement 7 gets a +1, also statements 9 and 15. Statement number 5 gets a +2, also statements number 10 and number 13 get a +2. In the second Q sort, -2 goes to 9, 14, and 1. -1 goes to 5, 10, and 13. 0 goes to 7, 6, and 8. +1 goes to 2, 12, and 4. And +2 goes to 3, 15, and 11. So there are 2 Q sorts.
Just 1 second. Just one thing just occurred to me. You know, I ain't very this nice. This is
That's quite all right.
Just
This happens.
in my mind as you were doing
That happens from time to time. People will actually. You aren't left-handed, are you?
Well, no, I just am used to thinking of positive on this side and that.
Because the reason I asked is it happens more to left-handed people than it does to others. It doesn't matter whether you go from +2 to -2 or -2 to +2. That's irrelevant. But sometimes some people prefer to think of it one way. I suppose normally we would think of like left-right progression, like when we read that it would go from +2 on the left. Those things which you agree with most. But sometimes things get scored the reverse. What happens is that person's factor loadings end up being on the same factor as they would have been but it's a minus 0.6, and everybody else is plus 0.6, and you wonder about this weird person. The person's not weird at all. The person scored the Q sort backwards, and therefore it doesn't change anything. It just means that there is not a bipolar factor, unless there were a lot of other people legitimately at that end of the factor. So it really has no effect on the outcome. The factor analysis would be no different, whether it's a plus or a minus. The particular line associated with that person would be reversed. So that could be easily done after the analysis. So at any rate, we're going to get a correlation this time that actually reflects the opposite of the extent to which these two people are related. Incidentally, when you're scoring these, particularly when you're entering them, sometimes something will happen, as in this case, where there's two statement 11s for Peter Schmoke, and there was an error in either scoring them or entering them. If the problem is entering them, then you as the terminal operator can look back and see where you made the error, but sometimes it is the case that the person has scored one statement twice. Sometimes that doesn't matter. If the 11 had been given a +2 and the 10 had been given a +1, you could flip a coin and change them, because that's not going to affect the factor outcome hardly at all. If the 11 was given a +2 and the 10 was given a -1, now you've got a big difference. But usually when you go back and look at the statements, it's pretty obvious what the problem was. It's, that given these statements that the person agrees with, he's going to agree with 11, not number 10. And so you can make those kinds of judgments. It starts getting more borderline when you have one that's a +1 and one's a -1, and the person might have done it one way, or the person might legitimately have done it the other way, and it's hard to rule out. So don't necessarily throw away a Q sort just because there's an error. Usually it's quite clear what the character of the error was, and you can save the response, and it's still a useful response. And when you have a more reasonable number of statements, 30, 40, 50, sometimes it will be 2, 3, 4 errors. Sometimes it can be resolved. And one of the good reasons for using a forced distribution is that you can resolve the errors usually. If it's a free distribution and there are two +11s, or if there's 3 statements that are out of whack, since it is a free distribution, you may know that statement 11 either gets a +3 or gets a -2, because that's where the two 11s. But you have the slightest idea where the 10 goes when you get done. Because it's a free distribution, so that there's no blank that's left over. Because the person when they use a forced distribution, there is a specific blank that's left over. 10 must go there because there's another statement. We need such and such number of statements under this column, and therefore that must be where the 10 goes. But when it's a free distribution, you don't know. And it's very frequently the people who use the free distribution who make the mistakes, because they do use the free distribution. And then they decide to change a statement, and they get confused, and for whatever reason, they end up scoring number 17 twice, but they miss statement 7. And whereas when you use a forced distribution, it's harder to make a mistake when you're scoring them. So that's a practical reason. Okay. For calculating the correlation, all we need to know is the differences may be by 1. We may have a difference of 1, or we may have a difference of 2, 3, 4, or 5. That would be the biggest difference from a +2 to a -2. And all we have to do is to count up the number of differences, ignoring the ones for which there's no difference. Like both of them are -2, we can just ignore that. But here we have a difference of 3, so we can put a little tick there. Here we also have a difference of 3. Here we have a difference of 2. Here we have a difference of 3. Here no difference. Here a difference of 1. Here no difference. Here a difference of 3. Here a difference of 3. Here a difference of 2. Here a difference of 2. A difference of 3. No difference, and a difference of 1. So these were all of the differences. 2 of these, 3 of these, 6 of these, none of these, and none of those. So this is the frequency with which each of these differences occurs. For computational purposes, we need to square the differences. D squared, the difference in score between the two Q sorts. These are the differences here. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and we don't need to calculate 4 squared and 5 squared because those don't occur anyway. This points up another important point, incidentally, in correlational theory, as well as the way people do Q-sorts, namely that those things that are at the extremes count the most. And in a way, you can think of certain statements getting the amount of weight that they do as a function of the square of their difference from 0, so that if it's plus 4 squared is 16. Therefore, this statement should count a whole lot compared to one that's under plus 2, squared is 4. One that's 16 should count roughly 4 times as much. So that those on the extreme count most. And when you interview people about the Q-sorts afterwards, they do count most. They're very concerned about these things under plus 4 and minus 4. The things in the middle, you ask them after they've Q-sorted, well, what about this one under 0? And they, I don't know. I didn't really see what it was, what the big thing was, or I didn't understand it, or for whatever reason, it's usually affectively neutral. That was a very important thing to Stevenson, that existentially, independent of the Q sample, of the subject matter that you're studying, independently of national differences, independently of conditions of instruction, independent of anything, the 0 point, theoretically, means the same thing, means nothing. And nothing means the same thing in any kind of language, any kind of culture, on any kind of subject. And therefore, that is the point of origin of meaning. Things take on meaning as they descend from the middle range of no meaning, so that this was the sort of the existential starting point of meaning. That's not to say that some Q samples may be overbalanced in some kind of way, so people are putting, there's a lot of statements they agree with, slop over in the middle, but as a theoretical matter, the 0 point doesn't matter much, and in fact, when you interview people after the Q-sort, that's quite typical. The things that are under 0 don't much matter to them, and so you can verify that in any particular setting.
Can I just check on that?
Yes.
Given that it was a forced sort, we really had to have as many under 0 as under everything else. I doubt that in reality there are as many things that we have no interest in as the things you're interested in. Particularly given that everyone here has come forward with conflicts, which has meant going to a lot of effort. I imagine that they're probably interested in all of those things. Certainly in my sort, everything was ready to see this important and crucial. Validated as such. I just had to be there because it wasn't as important as something else.
Well, certainly as a relative matter, this statement holds still. And there have been doubts expressed about that as well, but in fact, when we come back to people, a month later and ask them to Q-sort again, if all of these things were of equal importance, then the next time around, those that were under 0 would be under plus 1, and they, but in fact, they end up Q-sorting them about the same way they did the first time. They'll correlate with themselves, 0.8, 0.9, or something of that nature. So as a relative matter, then, it's still the case that these under 0 are relatively less important. This was also a very hastily done Q-sample. It's not complete. If we'd have had more time, a larger number of statements, and so forth, we might very well have gotten... And plus, those that are under -2 are just as important as those under +2, in the sense that those things that I disagree with are just important, as the things that I agree with, is like in my self-description. I am not whatever's under +4, and I am not these other things that are there, but I am things that are under +4. Those things in the middle normally don't matter. So a well-constructed Q-sample usually does have this area of affective neutrality. And in fact, the limited number of studies that have been done in which people have been left on their own devices to use whatever distribution they want, and then we use the normal statistics to determine whether this distribution departs significantly from a normal curve. For example, measures of kurtosis and skewness and so forth, differences in mean between the way you do it when it's forced versus when you are allowed to use free distribution. You'll rarely get anything that's different from a normal curve. And there are reasons for that back in psychometrics. B.B. Sinder's law of affective equilibrium, that given back then they were doing studies of olfactory responses, and so you would smell all kinds of things and rank them from those that were positive smelling and it turns out that if there were, more of them that were actually positive, the range of scores, you start adjusting your subjective middle. to take into account the stimuli that you've encountered. That this smells pretty good, but this other one smells even better, so this one gets downgraded psychologically. So that there is a tendency to establish a kind of affectively neutral middle point.
Is that how you respond to people who at first blush say, wait, there are way more statements or smells I feel positive about than negative? I mean, actually, I myself had that problem. I don't think my midpoint is where it ought to be. How do you respond to people?
Well, again, as a relative matter, there's no problem. That these things are relatively more.
And if there was
and if there was an occasion in which you, particularly on the basis of the interviews afterwards, you had the feeling that, that people were agreeing with more of them, you just sort of adjust your interpretation accordingly. The Q-sample scores, +4 and -4 and so forth, are to help the person with the sorting process. They're not to be taken as absolute values that they associate with particular items, but just to help in the process. We've even done it where we just put a plus under one end and a minus under the other end and leave the middle undefined as what they are. Any of those kind of changes do not affect the factors that come out of it.
Is there any difference in choosing the numbers? For example, instead of +2 or -2, you use all positive numbers, 1 to 5?
No, as a theoretical matter, again, the continuum from plus something to minus something with 0 in the middle is to reflect the idea that theoretically you have this affectively neutral. In the studies of olfaction, for example, back in the 30s and 40s, water, if they were smelling things, water would inevitably get the 0 spot. There were some things that smelled putrid, bad. There were other things that smelled good, and water got under 0. And the goal in having a comprehensive set of stimuli, statements, is that there would be some that just wouldn't matter too much. Very few that matter a good bit, and they're very stable. You get a person with Q-sorted ones that are under +4 and -4 turn out to be about the same, because those things people are very sure about. Those in the middle, when they get a +1, a -1, and so forth, they dance around a bit more because there's less stability, because there's relative absence of feeling. And again, if you have a badly skewed set of statements, it's very important to get a good comprehensive set of statements. And again, we were rushed. We didn't have time really to devote a lot of attention to it, but we could. So the correlation in this case is gotten by taking the frequency times the square differences. 2 1s is 2, 3 4s is 12, 6 9s 54, 66, 68 for a total. The correlation is gotten by starting off with a perfect correlation and then subtracting from that the extent to which 2 Q sorts are different from one another. If they were identical, it would be 1 minus 0. You'd have a perfect correlation every time one of them gave a +2, the other one gave a +2. There'd be no difference. We sum up all of these square differences, which is 68 in this case, and we divide by some constant. As long as everybody's using the forced distribution, it's a constant, and it consists of simply the sum of squares of associated with the 2 Q sorts. So these went from -2, -1, 0, +1, +2, and there were 3 under each one of these. So the sum of squares associated with this first response is there would be 3 minus 2's. So -2 squared would be 4, and there are 3 of them. So 3 times 4 give us 12. 1 squared is 1 times 3 would be another 3. So that would be a total of 15. The other side of the Q sort is also going to give you 15 as the sum of squares. So if we say times 2, that gives us 30. And if we have 2 Q sorts that we're looking at, you have the sum of squares of 30 in one Q sort, the sum of squares of 30 in the other Q sort, so that would be 60. And that's all this constant is in this particular case. So that what this constant is going to differ from study to study depending on the shape of the distribution, the range of the distribution, and so forth. So in this case, what we have then is 1 minus 68 divided by 60. 68 divided by 60 gives us 1.13. So it's 1 minus 1.13, which is obviously going to be minus 0.13. And since the Q sort was scored backwards, it would actually have been a plus 0.13 had the person scored it straightly. So that's all the correlation is. It summarizes in one number the extent of the overlap or similarity in the 2 points that are of view that are being expressed. So, to get the correlations then for this particular study, this program is very fast, at least on most computers. All we have to do in this particular case is to select option 3, and bingo, we have the correlation. Now, of course, this is a small matrix, 6 by 6, but even if it's, 50 by 50, it's, at least on the mainframe, you get it in about 1 or 2 seconds, and it correlates, and then it factor analyzes just as fast. So it goes very quickly. The correlation matrix now, if I put X, I can still, let's see, do I have to jump? No, I would jump back to MS-DOS at this point if I want to show the correlation matrix.
Show to the correlation file. You can leave it open and then.
Well, I'll come back to it because it'll be in the listing file. I'll not mess with it for fear that I'll jump over to MS-DOS editor.
Yes.
Yeah. Whoops. I don't know how now.
Yes, Untitled.
Let me come back. I'll come back to the correlation matrix later. The Centroid program, Centroid factor analysis, which is just not used anymore, and I'll press 4, and it's already factor analyzed all of that. In this particular case, it will only give 6 factors because there are only 6 Q sorts. The default is usually 7, and practically there's usually only 3 or 4 factors that are actually at issue, so 7 is way more than enough typically. The Centroid method is not to be found any longer anywhere. I suspect that PCQ and Q method are probably only the software packages in the world that have the Centroid method, because most statisticians regarded Centroid method as simply being an approximation in a statistical sense of the more precise methods like principal axis and principal components and other modes of factor analysis, and therefore thought Stevenson was a little quirky for wasn't really aware of modern developments or something of that nature for sticking with the Centroid method, but really had very precise reasons for advocating the Centroid method from the start, because he did not regard the Centroid method in statistical terms. He wasn't thinking of an improvement in a statistical sense, but was thinking of the Centroid method having certain characteristics to it, namely that the solution was indeterminate, as being precisely what you needed if you were going to use factor analysis as a way to probe the data, as opposed to conceiving of it as a way of finding the structure of the world as it really is, say in some kind of least squares or other kind of sense. So for him, he was interested in getting the factors and then being free to rotate as a way to look at the results this way or to look at them that way and so forth, because since it was indeterminate, there was no right answer. So by rotating the factors, you weren't violating least squares or any other kind of principle. And you could therefore use that to look at the data. And that's precisely why he wanted it, and there's no way to improve on that. In fact, if you use these determinate methods, they give you a solution, say some least squares or other kind of solution. But that's no guarantee, getting back to the idea of operancy, that you're looking at the data, so to speak, the way it really is. We have to be cautious about that, put that in quotes, but you may not be looking at it in the most, in the best way to look at the data. If you have some kind of knowledge about some group, whether it's a political group or some other kind of group, and some sort of a priori idea of how they're supposed to look in some kind of way, you can get a solution that features that particular way of looking at it in the factor solution, and Verimax or any other kind of automatic procedure may not get you that. Sometimes he used Verimax and other kind of methods of rotation, but typically not. So Centroid is indeterminate, and there are good reasons for it. I don't have time to go into it in great detail.
Question?
Yes.
If you then perform the IQ study by using another statistical package, are you saying that you may not get the same kind of results because of the lack of the Centroid?
The original unrotated factors will look pretty much the same, whether it's Centroid or any other.
Right, so rotated, but once you rotate by using either Centroid...
You may or you may not. I mean, the data that you're looking, I mean, the relationships that you're looking for may not be in what Verimax would recognize as simple structure.
So are you recommending that we then, when we perform a few studies, that we use only the software that has Centroid instead of doing Verimax?
Well, I'm saying that the Q method software program and the PCQ program were set up with Stevenson's ideas in mind, which included incorporation of the Centroid method because of its indeterminate and because it then permitted judgmental rotation to be used. It's very difficult to intervene into SPSS or SAS or any of those others and do some kind of judgmental rotation. And Stevenson was quite willing to let our methodology have all of its methods and all of its assumptions to do what it wanted, so long as they would be willing to let Q march to its drummer, which is different. Most people don't understand what it was that Stevenson was trying to do, and when they criticize it on statistical grounds. And the points that Stevenson was trying to make were not statistical points. His reason for doing those things did not have anything to do with statistics. That is still a great secret to the psychometric world, and is one of the most difficult things to get across. To the Q world, to a large extent, I would say also. But increasingly, I think more and more people, because of the availability of these software packages, are availing themselves more of them.